Okay, this is for the level 2s that are being taught milling at the moment. This is part of your learning outcome 4. And if you are on the level 3, you can also use this resource for your learning outcome 4. It's for tolerances and fits with regards machining. Now, in your design process, a designer will, say for instance, design this shaft. Okay, now this shaft is 50 millimeters in diameter, but as you can see, we have 50 millimeters and 50.981 millimeters. Now, the reason why it's like that is because the manufacturing process. To get something really accurate at 50 millimeters bob on all the way through is extremely time consuming. So what we have is we have the tolerances. Now, a tolerance is basically the algebraic difference between the 50 millimeters and the 50.981. Right, so you subtract one from the other and that will give you your tolerance. This leads us on to what we call limits and fits. Now, you have 3 types of fit. You have a clearance fit, commonly known as a sliding fit. You have an interference fit, which is commonly called a force fit, and a transition fit, which is commonly called a push fit. Now, those of you that have been in manufacturing, or you've done some form of apprenticeship, or you're doing some form of apprenticeship, and you're working with machinists, the difference between the 3 will be the size of the hammer you hit it with, and I'll explain that in a moment. So we have a clearance fit. So the first thing that we have is we have a hole in a piece of steel. The green area denotes your tolerance zone. So we then have a shaft, okay, and the shaft is made to fit inside it, and the 2 red lines denote a gap. So that rod shaft can slide into the hole, and there's a little bit of a gap. All right, so it slides in and it slides out quite easily. So that is your clearance fit. We then go on to the interference fit, or transition fit. Okay, same thing, same piece of steel, same tolerance zone. What happens is that the shaft is made exactly to the size of the hole. So you'll use some kind of oil, a lubrication or something like that to ensure that that fits in. If it doesn't fit in properly, you can tap it and that will slide into the hole. The last one, they're in the wrong, slightly wrong order, is you have your interference fit. So same thing again, piece of steel, tolerance zone. However, this time the shaft is too large. If you look at the 2 lines, all right, that is the size of the hole. So not only are you going to have to use some kind of oil or some kind of lubrication, but you're going to have a bigger hammer and you're going to have to hit that in, and it will fit, but it will be an extremely tight fit, and the chances are that once that fit is together, it's not coming apart. The other 2 can come apart. Now, in your activity pack, okay, you will see this image, and you will have to draw this inside your activity pack. So feel free to freeze the video and just copy what you see.